Welcome everyone. The question that is shown on the screen, it is 25 part B, and this is the odd in the set 1 of the CBSE 2025 physics question paper. An electron of mass 9 into 10 to the power minus 31 kg and charge is 1.6 into 10 to the power minus 19 coulomb is moving in a circle with a speed 3.2 into 10 to the power 7 meter per second in a magnetic field 4.5 into 10 to the power minus 4 Tesla perpendicular to it. Okay, so here we can say that here the magnetic field is perpendicular to that of the region like this, and the magnetic field is uniform. Okay, magnetic field is uniform like this. Okay, almost I am trying to draw all these are equidistant. Okay, so in this uniform magnetic field, in this perpendicular magnetic field, an electron enters. Okay, and when an electron enters, obviously it will follow a circular path, because we know that the Lorentz force, which is basically nothing but a no work force which is acting on it, and due to it it is the directions of the flow, we can say. So what will happen, obviously the mv square by r, which is called the centripetal force which is needed for this rotation, that is basically given by qvb. Okay, which is a Lorentz force. Here v and b are perpendicular to each other, so sine 90 degree I have put already 1 here. So from here we can get the radius of the circular path, that is r equal to mv divided by q multiplied by p. What is the mass? The mass is 9 into 10 to the power minus of 31. The velocity is 3.2 into 10 to the power 7. The charge is 1.6 into 10 to the power minus 19. The magnetic field is 4.5 into 10 to the power minus 4 Tesla. Okay, so very simply 1.6 and 3.2 cancels out and becomes 2, and 4.5 and 9 cancels out and become 2. So it will become 4 multiplied by 10 to the power minus of 31 plus of 7, minus 19 goes up, so plus of 19. Okay, minus 4 goes up, so it will become plus of 4. So 19 plus 4 is 23, 23 plus 7 is 30. Okay, is 30. So obviously it becomes 4 into 10 to the power minus 1. So this will become 0.4 meter. Okay, so this is the radius of the circular path. Clear? Now it is asked about what is the frequency of the revolution. Okay, what is the frequency of the revolution? So for that, let us say this is part 2 I am doing here. Frequency of the revolution. Frequency is obviously 1 by capital T, inversely proportional to that of the time period. What is time period? Time period is 2 pi smaller divided by v. If the radius is r, then for one complete round, if it takes, obviously it is circumference, the distance covered is circumference, that is 2 pi r divided by the velocity. So this will be v divided by 2 pi r. What is v? V is mv by qb. What is r? R is mv by qb, so it is v divided by 2 pi, it is mv divided by qb. Okay, so obviously v and v cancels out, so this will become qb divided by 2 pi m. So obviously from it, what is the value of the q? 1.6 into 10 to the power minus 19. Okay, what is the value of the magnetic field? 4.5 into 10 to the power minus 4. Okay, This is 2 pi. Mass is 9 into 10 to the power minus 31. Okay, so obviously here this 4.5 and 9, it is 2, it becomes 0.8. okay, 0.8, 0.8 and here is 2, so it will become 0.2. It will become 0.2. So this will become 0.2 by pi. We can say this will become 0.2 divided by pi multiplied by 10 to the power minus 19 minus 4 plus 31, because 31 is in the denominator. So 19 plus 4 is 23. So minus 23 plus 31. So it will become 0.2 divided by pi multiplied by 8, 10 to the power 8 meter per second. Okay, so see, it is of the order of the light's velocity, 0.2 by pi. Obviously it is less than that of the 3 into 10 to the power 8 meter per second. Obviously it is less than that of the light, but it is of the order of 10 to the power 8. So here I think you have understood that mass becomes the relativistic now. Question number 3, it is about the energy. Okay, it is about the energy. So I am moving to the next. The energy is not changing. Energy remains constant, but it have the energy. What is that? Half of mv square. Because after entering into the magnetic field, it starts rotating in a circular path with a certain velocity. And that velocity, if you see, that velocity, expression of the velocity, if you try to find it out, what is the expression of the velocity from this expression? Okay, from this expression, if you try to find it, what is the expression of the velocity? I am doing it again here. That is mv square divided by r equal to qvv. Okay, so v is equal to qvr divided by m. Velocity is equal to qvr divided by m. So that is determined by the charge, determined by the magnetic field, determined by the radius, okay, and determined by the mass. And all are constant here. Velocity remains same. Okay, but here I am not considering that is the mass is relativistic. Let's discuss this. Actually, the velocity is of the order of that is 10 to the power 8, so the mass should be relativistic. But here I am considering that mass is not changing because nothing is said here. So 9.1 into 10 to the power minus 31 multiplied by qvr by m. What is q? Q is 1.6 into 10 to the power minus 19. Okay, what is the value of the magnetic field? Value of the magnetic field, C. Magnetic field is 4.5 into 10 to the power minus 4. So it is 4.5 into 10 to the power minus 4. What is the value of the radius? The radius is we have calculated 0.4 meter. So it is 0.4. It is 0.4. That is 4 into 10 to the power minus 1. Mass I am putting again here. Okay. So it is 9 into 10 to the power minus 31. Okay. 9 into 10 to the power minus 31. So what will happen? So obviously 4.5. 2 cancels here, and if 2, it is 0.2. Okay, so 0.2 into 1.6, it becomes 0.32. 0.32 multiplied by 10 to the power minus 19. Okay, minus 4 plus of 31. Okay, so 0.32 multiplied by 10 to the power minus 19 minus 4 is minus 23. So it is of the order of 10 to the power 8. Okay, this is order 10 to the power 8 meter per second. Okay, so we can say it is also 10 to the power 8 meter per second. So 0.32, actually the value is, it is not 3. So we can say it is 3 into 10 to the power 6. Okay, Okay, after proper calculation we have obtained that the order is 10 to the power 6. Okay, 10 to the power 6 means obviously here it is not relativistic at all. Then what that value came here there? Okay, that is not the meter per velocity, that is the frequency, so that is in the order of the hertz. Okay, sorry, that is there is a frequency, that is not the velocity, it is of the order of the, it is frequency, so it is in hertz. So it is 3 into 10 to the power 6, so obviously it is not relativistic. Okay, so it will be 3 into 10 to the power 6 whole square. So this will become 1 by 2 multiplied by 9.1 multiplied by 10 to the power minus 31 multiplied by 9 multiplied by 10 to the power 12. Okay, so 9 into 9, so it is 81.9 divided by 2 multiplied by 10 to the power minus of 31. Okay, 10 to the power 12, so I can say this is plus 12, this is plus 12. So 81.9, it is 40.95 into 10 to the power minus 31, so it will be minus 19 joule, minus 19 joule. Okay, if you want to find it out in electron volt, that will be 40.95 into 10 to the power minus 19 divided by 1.6 into 10 to the power minus 19, and this is now in electron volt. 10 to the power minus 19, 10 to the power minus 19 cancels out. Okay, so it will become simply 409.5 divided by 16. Okay, so 409.5, so 16 2s are 32. Okay, 8 9, so it is 5, so 9.5, so we can say it is approximately 25 point something joule, sorry, electron volt, not joule. I have converted in electron volt. Joule is 40.95 into 10 to the power minus 19 joule. So what we have obtained, radius of the circular path is 0.4, frequency is 0.2 divided by pi multiplied by 10 to the power 8 hertz, and energy, this is the kinetic energy here, it is 40.95 into 10 to the power minus 19 joule, or 25, approximately 25 electron volt.